Good morning, everyone. Thank you for joining Megger Asia webinar. I'm Grace from Megger Hong Kong. Today, our topic is case study sharing, extended analyzer for extended range current transformer. It is a live webinar presented by our Meggereastasia technical support group leader, Mr. Michael Evangelista. Please note that you are automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box, which you can see on the left of your screen. We'll answer your question at the Q&A session. At the end of the webinar, please help us fill in the survey, which is on the right-hand side on the screen. We'll be sending the presentation materials to those completed the survey. Attendees will be able to download an attendance certificate after they have finished the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time by email. So without further delay, let's start now. Thank you for joining us today. Michael, I'll pass the time to you now. Thank you.
Thank you, Grace, and good morning, everyone from Philippines here. As you may know me already, my name is Michael Evangelista. I'm the TSG manager of East Asia region for Megger. And today I will be sharing to you our case study. This is actually a case study on how to verify that the city is an extended range. But before doing so, let me introduce you to our today's topic. As you may know, distribution utilities or electric co-ops in the Philippines or maybe in any part of the world, they are engaged with extended range cities. They are buying more. This is to consider replacing their old cities with the ERCT, which they believe can help them improve their revenue metering. However, the problem arises when the purchase is made from unreliable or fly-by-night supplier who just won the bid through pricing. Once the city is delivered, then they don't have the means to check if the cities delivered are really an extended range. Okay, so this is how this is the problem is. Now for the agenda, of course, let me explain to you what is the extended range current transformer first. Extended range current transformers are designed for power distribution utilities, especially for metering application or for revenue metering. It accurately measures a wider range of current without making any physical changes in the connection. But of course, the different with the other cities, for example, with the dual cities, they have two ratios, meaning if they have high current load, then they will use the higher ratio, and if they have low current load, and then they will use the other ratio. So that is the difference. This extended range has a better accuracy than the standard one. Normally, these current transformers have been designed using magnetic materials that minimize excitation losses and a winding distribution that eliminates stray losses. Extended range current transformer can increase distribution utility revenue. So we are talking of money here. Of course, the accurate the cities that you have, then you can have more revenue, you can have more money. In the past, cities were designed to accurately measure down to 10% only. Okay? And inaccuracy, of course, on systems with variable loads. So for example, if you have factories, right, industrial parks, and then they turn off some of their motors, of course, they will have this low load, and that is when or where the inaccuracy starts. Also during off-peak, where the load is running around 5% only, then the inaccuracy of a standard city is getting high. With the ARCT technology, I'm not promoting ARCT here, but I just want to explain to you the ARCT. This extended range city can accurately measure um, down to 1%. Please take note of this, down to 1%. They are very, very accurate. So, of course, if you have this kind of accuracy, then you can perform very well at a lower current level. Looking at the standard, the C37 or C57.13.16, it discusses about the different classes accuracy. So for example, here we have a class 0.3 meaning the class 0.3, or you will obtain 0.3% error from 100% of rated current up to 100%, 50% of the rated current or the rating factor. Now, if you go down to 10% to 99%, then the guaranteed accuracy is only 0.6%. Looking at the 0.15 class here, same thing. If you go, or if you have 100% rated current, then you can have 0.15% error. And from 5% to 99%, maybe 99.99% current rating, then you can only have 0.3%. And looking at the 0.15s, which is more accurate than 0.15, the 0.15, here, S can have a 0.15% accuracy down to 5% of the rated current. Now here, extended range cities of 0.15, for example, this is for example of 0.15. Look at this graph here. The 0.15% can go down up to 1% of the rated current, meaning the extended range city is accurate up to 1% of the rated current. Even if the load is 1% of the rated current, meaning you can obtain 0.15% error. There's a better view here. Extended range can go 1%. Right? Now, these are the challenges who purchase. These are the challenges for those who purchase ERCTs. So it starts with, how would they know if they really bought the correct and specified extended range cities? Remember that these cities, or they are purchasing it through bidding process, meaning everybody can participate, anybody can comply and win the bid through pricing. Right? But the problem is, how would they know if it is really an extended range? Another thing is that, what is the highest accuracy this ERCT can provide? And also, the biggest problem is what equipment to use to check these ERCTs. These are the challenges of the end user. Now, we would like to share these case studies that we have on how to determine if the ERCT or the city is an extended range. Okay, so first thing that we did, we gathered information or checked the nameplate to be verified. So as you can see here, yes, this is an ERCT, all right, ERCT. But how would we know if this is a real ERCT? It displays 0.3B 0.5, so meaning the accuracy class is 0.3. So we are expecting 0.3% here, and the burden is 0.5, and then the ratio is 30:5. Okay, so we are verifying this 0.3 here. Now we are connecting the MBCT to a CT, and the good thing with the MBCT is that it has a displayed diagram on how would you connect the equipment to the CT. So it's very simple, very easy to understand. And then, this is one good thing with the MBCT. We can do nameplate estimate. So meaning to say, even if you don't input anything on the nameplate values, for example, you have a city that doesn't have any nameplate, then the MBCT can determine the nameplate values, can estimate. So as you can see here, we did not put anything in this case study. We did not put anything aside from we changed this number of taps because the terminal of the CT is only 2, right? But of course, you can test up to 5 terminals simultaneously. This is one of the features of the MBCT. So here we did not put anything. But please take note, when you do nameplate estimate, this is just based upon the theoretical calculation as per IEEE, IEC, and ANSI guideline. Of course, for most accurate nameplate information, you need to input the actual city nameplate. But in this case, we want to identify if it is really an ERCT, then we don't put anything because we want the unit to estimate the actual accuracy of the CT. Okay? But remember, the MBCT will just indicate the closest number or the closest accuracy class, for example, that he found out from the test result. So for example, he sees this saturation curve, he sees this ratio, then he will indicate the closest accuracy class based on the theoretical calculation. All right. Then the good thing with the MBCT is that we can run all tests. So meaning to say it will do this test, the mag, saturation, ratio, winding resistance in just one go, in just one play button. So now we got the result here. So the MBCT finds that the CT is maybe 0.15s because it it comply or it passed the 0.15s values based on the result. But as you can see here, this is 0.3, right? So meaning to say this is not just 0.3. According to MBCT, I can see that the CT is around 0.15s because of this result, maybe because we got this error, right? So we are not sure yet if the CT is an ERCT because we don't have the value for the 1%. 1% rated current, right? The good thing with the MBCT is that it will display all the error at different rated current. Not all, but you got the information of 1% rated current value. So as you can see here, because this is a 12.5 burden, then let's look at the 12.5 burden here, and it says at 1% rated current, I got 0.214. Looking at this, 0.214, and looking at this value here, we get the 0.3, meaning to say it is 0.3 up to 1% of the rated current. Meaning to say this ERCT here is a real extended range CT. Okay? And the good thing with the MBCT is that it will give you calculation at different burden. So if, for example, your burden is only 6.5, then it will give you this accuracy at different rated current. If the burden is 3.13 BA, then it will give you this accuracy error at different rated current. Okay. Now, as you can see at the reading and the result, we change the nameplate. You can manually input the correct nameplate now after the estimate. You can input the correct nameplate values, and then you will have this result. It's still the same. It is an extended range because it is 0.3% up to 1% of the rated current. Better than 0.3 actually because it is 0.214 only. And looking at the parallelogram for metering application, you can see that the value or the X are inside the box. So meaning to say, this is a very, very accurate CT here. Okay. Now, to check whether the MBCT is really displaying the correct values, we tried to test a non-ERCT or not an extended range CTs. So here, you got an ANSI CT, you got 0.3 B05 and 12.5 BA. This is the nameplate value. Now, the MBCT estimated that yes, it is 0.3, it is a B05, and it has a 12.5 BA. So the MBCT estimated the CT correctly. Nameplate versus measured are is very identical. So, looking at the rated current to check, maybe it is an ERCT, who knows? Looking at this rated current here, at different error at the rated current, different rated currents. As you can see here, he fails on 1%, of course. It is not 0.3 on 1%. It is not 0.3 also on 5% of rated current, but it is 0.3 on 10% up to 100% or 200% of the rated current. So meaning to say, this is just a standard cities. The accuracy starts from 10% to 100%, 50% of the rated current. So it is a non-ERCT. All right. Now, introducing to you our Megger instrument on determining those ERCT or verifying this ERCT. We have the MBCT and the MRCT. The difference between the two is that for the MRCT, you get the 2 kb transformer here. So meaning to say it is more heavier because it weighs around 37 pounds, while the MBCT is only 18 pounds, right? And the other difference is that the MRCT can do CBT ratio, or we can test capacitive voltage transformer. Unlike with the MBCT, we cannot do the CBT. Well, anyway, the CBT is being used only on the transmission line or the higher voltage, right, system. So if you are a utility company or the distribution utility company, then you don't need MRCT, but MBCT will be enough. These are the distinctive features of the product. It has the ability to test both BT and CTs. It is easy to use. Just one button, as you have seen it, run all tests, and it will perform all the taps, all the tests that is included in the software. It will run in just one play button. It is a leading test duration because it can do the 5 simultaneous taps. It can test 5 taps simultaneously. It is the smallest and lightest secondary voltage injection in the market, the MBCT. It can do CT knee point up to 30 kb. It can test metering class CTs. It includes single phase relay, but it is an optional. So MBCT and MRCT can have single phase relay test set included. So that is optional, of course. It includes all the standard tests up to 2 kb for the MRCT. And then you can do group testing, demagnetization, knee point. Like I've said, in just one go, you can have all those results. Another thing, it can perform secondary burden. When we say secondary burden test, we are trying to test the actual burden of the city, right? The actual load of the city here. So for example, if you have a relay connected into the city, if you have a meter connected to the city, then we can measure the actual ohms or the actual VA of that burden. And so we can change into the setting, or we can put into the calculation, oh, this is my actual burden. What will be my accuracy on that burden? So you can put that in the nameplate value. So it displays multiple instantaneous saturation. So if you have 5 taps, then you can see 5 curves. And good thing is that it has integrated 1 kb DC insulation. You don't have to bring your Megger instrument for insulation because it has a built-in 1 kb DC insulation. It is compliant to ANSI C57.12.90, C57.13.1, and the IEC 66044. Right? Of course, the 2000 volts test voltage is only for the MRCT. So you can test the C800 class CTs. You have also a manual knob for control voltage, right? And the majority of the customers will prefer a knob to manually control a CT tester. And the capabilities and features, the only difference is that the CBT, right? And looking at the power, the software of these equipments, we have the Power DB. So as you can see here, you can select MRCT or MBCT here. This is the home screen. So as you can see, we can test CT, we can test VT, CBT, and relay if it is a fully packaged or a fully option. So you can run all tests, but you also have This is the setting tab. This is the nameplate tab. The test functions. So you can also do individual tests. If you want go directly to the ratio, then no problem. If you want to go to the saturation, no problem. But the good thing with the run all test is that it will do a sequential test. It will do the test in sequence. So for example, it will do the winding resistance first. But because we inject DC current on the winding resistance, it will do the demag first before the saturation curve or before the ratio test. So I would really suggest to run all tests because the MBCT or the MRCT will do the test in sequence. It knows what to do first, right? So looking at the setting here, you have the access on the saturation or the standard. So if the CT is ANSI or IEEE, then you can select ANSI. If it is a non-gap core or ANSI 45, so you can select standards here. Depends on the nameplate of the CT. You can change the color, you can change the tolerance setting. Of course, this is based on the standard, meaning these are the limits. And the good thing with the MBCT is that it has an automatic assessment whether the city passed or failed the limits according to the standard. So it will display pass if it is passed according to the standard and fail accordingly. Also, you can change the ratio error on primary or on secondary. You have the report assessment, so you can select what do you want to see in the report. If you want to see the ratio error table, graph, etc., the displacement. Okay, and of course, the good thing is that it will show you the connection diagram, so you can double check if your connection is correct. You have the knee point prediction. If it is enabled, then you will have a faster testing duration because it can already, it will calculate already the next point, just like that. No? Also, it has the leads check enabled, so to check whether your connection is good. Then you have the nameplate estimate as what we discussed in our case study. This is what we use. Of course, the number of taps if you want. And the good thing is that it has, of course, the option to change whether your saturation in the mag shall be done on AC or DC. Of course, according to the standard, you can do both AC or DC. If you do DC, then your testing will be faster because you are saturating much faster way. Unlike on AC, and if you do it in a nominal frequency, then your saturation or your excitation curve or saturation test will take longer. All right, so you can select AC or DC. Of course, some other equipment uses AC at a very, very low frequency to make it faster. But to us, we have the option to use AC or DC. This is the home screen, the MBCT. So as you can see here, we don't have the CBT for the MBCT, unlike with the MRCT. Okay, looking at the nameplate window, so you can test multiples of CT. For example, you have a set of 3 CTs, phase A, phase B, and phase C. Then you can put 3 CTs here. If it has 2 cores, then you can put 2 cores. The good thing with this one is that you can have one test form. You can have one test results for those 3 CTs. Unlike with the other equipment or the other brand, you need to print different test report for different CTs. So good thing with this one, if your CTs are installed in the substation, then you can have 3 results in one form, in one paper. Not in one paper, but in one form. You can also select the number of taps. Remember that the MBCT or the MRCT can do 5 simultaneous taps. You can change the label. You can put the name. You can select whether it is meter class, metering class, or protection class. the saturation standard, the accuracy class VA, and the actual burden. Remember, as I've shown you a while ago, we have this table, right? So if the VA is not there, maybe you are looking at a different VA, maybe you are looking at the actual burden, then you can put the actual burden here, maybe 0.1 VA at 9% or 0.9 power factor or 1 power factor, then it will display automatically in the test result. Even if you have done the test already, even if you have done the test already, you can put the value here, and then in the report it will change automatically. So you can put the ratio here if you don't want to do the estimate, right? And then you have also the manual control, this knob here. So if you want to experiment, if you want to do something, then you have the right to control the current or the voltage. You can control the current, you can control the voltage, so you can have the ratio. So these equipment also have a self-diagnosis check. So meaning you can check if the equipment is still working or in good condition. But it's not a calibration check. It's just a simple self-diagnostic check, right? So like I've said, you can test multiple cities, and also you can test a buried city, or the bushing cities. Those are bird cities. So you can test bird cities on a delta winding. So you can put H1. For example, this is your transformer and you have a city inside. Then you can connect the H1 and H2. Of course, you are measuring the voltage here. So you have the factor of 2/3, right? So voltage measured is equals to the 2/3 of the voltage V2. So when you measure the ratio, of course, this is the V1 over the V measured, and the corrected ratio is V1 over V2, which is equals to 2/3 of the X, right? Now, the good thing with the MBCT is that just check this in the setting, this bird city in delta connection, then it will automatically calculate the measured ratio or the corrected ratio. It will automatically display the value, which is corrected. Okay, you don't have to manually compute. That is one of the features of this MBCT. Another thing, if if you have, for example, if you have live tank and you have a CT both sides, right? So there is a capability that you can swap the test leads without physical, disconnection or connection, right? Without physically swap the uh, the test leads, then you can here you can just check, and then no need to swap the test leads physically. So you can test the city mounted on a transformer. Of course, you need to short. Anyway, if you buy our equipment, sir, we will also conduct the actual training at site. If you have, then we will teach you on how to do the bushing city testing. Right? And looking at the accessories, so as you can see here, we can test 5 simultaneous tap. This is for the MBCT. So same thing, very clear, very easy to understand, and simple. Right? Like I've said, we do test sequence. So when you do the run all test, it will do the test in sequential manner. And these are the report here. It will display all the taps, error and ratio. Error, you get the error here. You get the test voltage, you get the test current, you have the primary voltage, and the knee point, or the knee point voltage and the knee point current. You have the phase angle deviation, you have the polarity, and the winding resistance. Also, like I've said, we have the insulation resistance, so you can also include that one. So you can have 500 or more than at 500 volts. As you can see here, at 500 volts, my insulation resistance is more than 10 giga-ohm. Maybe they did not include the primary to ground here, all right? But you can also have values for primary to ground, secondary to ground. And also, This is the display of our saturation curve. So you can see multiple tabs here. So you get the voltage and the excitation current here. And like I've said, you have a multiple values of error at different rated current here, at different VA, a different percentage of the rated current, and of course the error here. Now, for example, if you put the actual burden here, maybe 0.7, 0.7 VA and zero point 0.9 here, then you will have additional information here without doing the test again. Just change the nameplate setting or go to the nameplate setting, add the actual burden, and then you will have the actual accuracy of the CT. Right? This is also the phase displacement here. So you can see the phase displacement at different rated currents. If you want to use that information, it's very useful also. And you can also have a graph here, as you can see, very clear. To me, if I am doing CT testing, I am looking at this graph immediately, right? So in this graph or in the parallelogram, I can already see if the CT has passed or failed the based on the standard limits. So I'm just looking at the graph in the parallelogram quickly to have a first glance if the condition of the CT. And also the good thing with the MBCT or MRCT, it has pass or fail value here, or if it will do automatically assessment based on the standard you selected. All right. And the good thing with the MBCT and MRCT, you can buy it with the display, so you don't need a laptop, you don't need a PC to control it. It has a built-in PC, but it is optional, of course, so you can buy it with optional display, right? So we can test with the MRCT, the VTs and CBTs, and these are the test leads or the connections. This is the report for the MRCT, so you can have the CBT here. All right, so I guess that's it. It's just a quick presentation of sharing my experience on the ERCT. And I would like to say this disclaimer: the MBCT can be used to help identify ERCT, but additional testing that verifies the design time parameters of the CT will be required to verify the CT is an extended range. We do not want to be held liable of them declaring it to be an extended range CT using MBCT and putting it into service and found it not being one later. Okay, so we are not, this is just a disclaimer. Another thing is that I would like to share those information about the ERCT. We got it from the RTG USA, Rich Instrument Transformer, Jewel Technical Paper. And of course, I would like to say a special citation here. Special thanks to John Paul C. Cabuenas, a sales engineer from Centray, who helped me do this case study. So this is the guy who gave those information and helped me do the testing with their own CTs. So guys, thank you for listening. So if you have any questions, you can contact Megger Hong Kong at megger.com, APACtsg at megger.com, or myself, you can contact. This is my contact details here, my email address. So Grace, do you have any questions?
Okay, thank you, Michael, for your wonderful presentation. So now it comes to the Q&A session. If you have any questions, you can type in the chat box. Michael will answer your questions. And for those of you who are leaving, please remember to fill in the survey, which is on the right-hand side of your screen. We'll be sending the presentation materials to those completed the survey. And also, you can download the attendance certificate at the bottom control panel, which is the icon on the right-hand side. And also, the recording of this webinar will be available in 2 days' time by email. So we'll spend maybe 5 minutes for any questions. So, hello, Michael. We have one question here. The first one is when measuring CT resistance value vary with the temperature, how do the equipment compensate for this?
That is a very good question, Grace. Yeah, the temperature is really related to resistance, right? So whenever there are changes on temperature, it will affect the resistance. However, when we do uh, uh, the resistance of the city here, and unlike transformer, so this is the difference. In the transformer, we are comparing phases, right? We are getting the difference between phases. However, in the city, if we are just doing individual resistance to analyze or to to assess the resistance of the city, we are just looking at the trending value or the historical value of the resistance. So yeah, the MBCT doesn't have any temperature compensation right now, but yeah, so the thing you can do is that you can compare with the identical or the twin unit for the resistance assessment. So at the moment, we don't have the temperature compensation.
Okay, thanks, Michael. The next question is how can we know the knee point value of the CT if we didn't find it on the nameplate?
Yeah, sometimes or most of the cities doesn't have the nameplate the knee point value, but yeah, this is the way you do the test with the MBCT and it will give you the information right away. Now, if you don't have MBCT and you want to do it manually, then you can inject voltage on the secondary side, increase the voltage, and observe the excitation current. Okay? So meaning to say, you are injecting different voltage level, starting from 0, 1, 2, up to the point that you can see a knee point. Now, there are two standards, right? We have the ANSI and we have the IEC. They both have different definition for the knee point. For the ANSI 45, if we are talking of the ANSI 45, remember that we are plotting the curve, right? We are plotting the curve, injecting different voltage and then resulting to different excitation current. After getting that curve, we need to plot a 45-degree angle line. So we need to draw a line at 45-degree angle, and that line, if it tangents to the it tangents to the curve, we need to find that where that 45 angle line tangents in that curve. The tangent. Um, so the tangent 45 or the ANSI 45 defines that the angle 45 line tangents or intersect on that curve. That is the point where the knee point is. Now, if we are talking of the IEC standard, uh, 10%, if I'm not mistaken, if I remember it correctly, 10% change in voltage will result to 50% change in current, then that will be your knee point. So for example, if you are going to use IEC standard, you need to increase the voltage by 10%, right? So if I increase from, for example, 2 volts to 4 volts, and then that that makes my current change from no 10%. So 2 to 2.2. So 2 volts to 2.2 volts, and it will result from, for example, 10 milliampere to 15 milliampere. Then that is my knee point. So remember, 10% increase in voltage resulting to 50% increase in current, that is the knee point as defined by the IEC standard. So that is a different ANSI where the tangent 45 connects the tangent that the angle 45 connects, And for the IEC, it is looking at the changes in voltage and current. Okay.
Okay, thank you, Michael. And
Or maybe they can watch my previous webinar about the basic of CT, VT, and CBT testing. I think I've done it 2 years ago. I have discussed it actually. Yep, guys, sorry.
okay, thank you, Michael. And the last question here we have is when we are doing CT tests on site and we get an unexpected result, especially when those CTs are not as stated in the nameplate. Do you have any recommendations on what to do? Do we need to redo the test?
Okay, when we are doing CT tests on site and we get an unexpected result, especially when those CTs are not stated in the nameplate, meaning to say your CT doesn't have any nameplate, then the good thing with the MBCT is that it will estimate the nameplate of the CT. So you can already assess the CT using those results taken from the MBCT result. You can already assess the accuracy, the winding resistance, the saturation curve, and then you can decide whether you put it back in service or not. All right, but to me, if it doesn't have any nameplate, I'm hesitant to use it anymore because physically it's you know it doesn't have any information. It will mislead the it will create confusion. It will mislead the person. For example, if it is a relaying CT, then it will it will create confusion to the relaying guys. But if you give them the result from the MBCT about the nameplate estimate, this is the estimation done by the MBCT, then they can of course refer to that value and then they can create the setting of the relay based on that result. But to me, if it doesn't have any nameplate, sir, maybe you can create a nameplate. You can do the nameplate estimate, then put the new nameplate recorded, or you can create a new nameplate. All right. But I don't want to use, a CT without nameplate.
All right, thank you, Michael. I guess we don't have any more questions. If you have any more questions, please feel free to email us to meggerhongkong@megger.com. You can also contact Michael directly, which is stated on his the PowerPoint. And please, you can also visit our website, www.megger.com/webinars for future webinars. And on next Thursday morning time, we have another webinar. The topic is Megger TDM series complete solution in one device for medium voltage power cable. So if you are available, please join us next Thursday. So thank you again for attending. Thank you, Michael, Bernardo, as panelists, and we hope to see you all again next time. Thank you, everyone.
Thank you, Grace.
Bye-bye.
Thank you, everyone. Bye-bye. Thank you, Grace. Thank you, Bernard.
Thanks, everyone. Bye-bye.
Hello.